There are a total of 6 sheep. The sheep claim that they have placed 6 sheep in this location. So there are 5 sheep: Amber, Brownie, Collie, Daisy, and Eden. I'll just call it A, B, C, D. We have 5 of them, and there are 6 spots for us. I'll put these guys in. Here, each of us can contribute as much as possible when we simultaneously put it in. But I heard Amber and Brownie fought. I wonder what the feeling is about what to do. They probably say not to include it. If you look at the back, what is the first problem? It's spacious enough for 5 sheep. They absolutely say not to put Ember and Boron together. Then, I think there are 2 ways to consider it. Omit case of putting Amber and Brownie together. In all cases, consider this method or directly write Amber and Brownie from the beginning. Also subtract opposite case and do it. I'll try both. First one is putting them in directly, putting in Amber and putting in Brownie. If you just put it in, no one has put it in yet. I'll start with Ember. There are 6 ways to put it in, so you can just put it in. Then, if Ember goes in, for example, avoid Ember and put it in. Then you can put in the remaining 5. There are 6 possible ways for Ember to go in at first. Since you can't put Brownie where Ember has put it, there are 5 ways. I need to put the rest of the CDs in, but it doesn't matter where they go. Since Amber and Brown are already separated, I can put A here and B here. If I put C here, it can go in one of the 6 places and overlap. We have plenty of space, so there are 6 options for C, D, and E. Thus, I can solve it like this. This is actually the simplest way to solve it, but I'll try subtracting the cases where they are together. Just ignore the fact that you can't put Ember Brownie together and think about all the cases. Since there are 6 possibilities for each individual, it's 6 to the power of 5. Subtracting the cases where Ember and Brownie are together means counting only the cases where they are together. Saying that Ember Brownie goes together means thinking of Ember Brownie as 1. So, you're thinking of placing it in this state. This is one of the 6 as a whole, and this is also one of the 6. When you combine A and B, there are 4 possibilities, right? So, it's okay to do it this way, whether you solve it from the left or the right, or calculate it by subtracting from the total number of cases. Anyway, the answer is the same. If you calculate it, it's 5 times 6 to the power of 4, which is 601. So, the result is the same. So, this is the solution for A, and when you consider B, you can place multiple items in A, but for B, the instruction is to place 1 item at a time, just 1 at a time. However, it is advised not to place Amber and Brownie together due to their shared boundary. Hence, they recommend keeping them separate. What is the intended meaning of this instruction? They say you shouldn't put them in like this, 1 by 1 with A. If you leave it like this, you'll be sharing this boundary. They say you can't do it like this. In that case, let's say A and B are like this, it won't work either. But I think this one works. It doesn't mean sharing the boundary, it means sharing the edge. So this one can be solved in 2 ways, either by finding it directly or subtracting it from the total cases. I'll try both ways. What happens if we find it directly? Put Ember in the beginning, for example, put Ember here. Then Brownie can't go here or here, so it's one of the 3. So if you put Ember here, Brownie is one of the 3 and Ember is one of the 6. Ember went in. Brownie is one of the 3 over there. If you multiply it by 3, why doesn't it work? What's the reason? This means that Ember can go in any of these 6 places. Then, when you put Brownie, are there always 3 options? If A is here, then 3 things are true. If A is here, then 3 things are still true. But if A is here, then there are 2 possible places where Brownie can go, here and here. So it's divided into 2 cases. That means we can't multiply 6 initially, right? We have to count it directly, don't we? So I want to count it myself. Then, after looking at the places where A can go first, we need to classify the cases where B can go in the same way. If A goes in here, there are 3 things B can go in. If there's a corner, there are 3 places where B can go. And if A is here, there are 2 places where B can go. If A is the same, it's the same here too, right? So we must differentiate this seat and that one here when you initially insert the Amber. So first and foremost, let's assume that Amber takes up one of the 4 available seats. 4 seats. What are the 4 things? either go in here or go in here or go in here or go in here. If Ember goes in here, if Ember goes in here, then Brownie goes in one of the three. So it would be multiplied by 3, and the rest, CD, just goes in one of the remaining 4. So it would be 4 permutation 3. Put Ember in, put one of the 3 brownies in, and then the remaining 3 go in the remaining 4 spots. So it would be 4 multiplied by 3 multiplied by 2. Give up 2? Not only that, but what I did was, when I put Ember here, Ember could also go in here. You have to think about these two separately. If Ember goes into one of these two, let's say 2 times Ember goes in here, then Brownie can only go in here. There are 2 cases where Brownie can go in. 2 times 2. In that case, if you put Ember and Brownie, you just put CD, so it's 4 times 3 times 2 like this. I personally found this, right? I want to exclude this one from all the cases too. Of course, you can also find it like that. Let's exclude it from all the cases. Just whatever, whether Amber Brownie shares the boundary or not. Let's just count it for now. Then, out of 6 Ambers, one of them, and out of 5 Brownies, one of them, can be found first as 6, 5, 4, 3, 2. And then the total cases are 6 times, 5 times, 4 times, 3 times 2. If you do this, it means you're putting in those 5 sheep. Let's exclude sharing the boundary here. When I think about other cases for sharing the boundary, I realize that you can share it like this and also like this. When I think about cases where Amber Brownie shares the boundary, there's not only sharing it horizontally like this, but also vertically like this. When I think about it like this, there are 1, 2, 3 cases of sharing the boundary. So there are 4, 5, 6, 7 things, right? And there's something like A and B, or maybe A and B are like this. So if we subtract those, it should work. In the case of sharing the boundary in reverse, 7 things multiplied by A and B, if we share them like this, whether we put A and B like this or like this, it's another case. Multiply it by 2. When Amber Brownie shared this equation, 7 times 2, it's not the end. We also need to add the remaining CDs, and there are no restrictions. So we can just put in 4 times 3 times 2 for the CDs. Yeah, that's why they're the same. Answer is the same, just the way to find it is slightly different, you know? Red is something I got, blue is what I subtracted from cases. Both are fine, doesn't matter which one you choose.